but glad you made it, and we are really looking forward to your presentation. So James is with GE Research, and he'll be telling us not about quantum dots, but instead about phosphors and how one can achieve narrow band emission using phosphor technology. So whenever you're ready, please do share your slides.
Okay, I'll turn my camera off and share my slides. All right. Well, thanks for having me, and I'm glad we made it through without too many technical glitches. But yeah, so my name is Jim Murphy, and I work in upstate New York for GE, and I lead a team of talented scientists. Many of them are listed here who contributed to this work, so I want to thank them up front. And today we're going to talk about, the previous talk was excellent on quantum dots. So today we're going to talk about something that competes with quantum dots in next generation displays, and is actually the bulk of the market. And those are phosphors. So phosphors are typically micron-sized particles, but we've developed a submicron type of narrowband phosphor to enable the next generation mini LEDs, micro LEDs, and luminescent color filters. So that's what I'll talk about today. Just a little bit of background here. The first few slides are more on marketing, but our narrowband phosphor is known as potassium fluorosilicate, so for a red emitter. And so it's abbreviated PFS, or you may have heard KSF, especially in Asia. It means the same thing. We first commercialized in 2014, and we've had accelerated into the display market very quickly. Our business model is licensing into the display industry. So we currently have 19 licensees, and our KSF containing phosphor can be found in over 60 billion LEDs that are used in the display industry. So it's really that red emission coming out of your display. Good chance that it contains our technology. So I think most folks in this crowd understand that to the bulk of displays today, you need blue emission, green emission, and red emission. The blue emission comes from the LED itself, but the green and red emission come from phosphors. And so the job of a phosphor is to absorb. What we do is we optimize the chemistry to absorb blue light as efficiently as possible, down convert, and then fluoresce in the desired wavelength range. Our red phosphor in particular, KSF, it emits with a peak emission at 631 nanometers. So right where a display needs red emission. It's very narrow emission, so that enables very high color gamut with no wasted emission in the near infrared, which would result in lower efficiency, and no emission into the orange, which would diminish the color gamut, the color quality. And to use this very narrow band emitting phosphor, you do need a license from GE. So feel free to contact us there. And the bulk of our revenue today is in this on-chip configuration. So the way that works is you have a larger size blue emitting LED. You mix the green and then our KSF phosphor into typically a silicone type of binder, and you deposit that on top of the LED to generate your white light. So I'll show you some data there. But there are other architectures and makes this very exciting. Things are moving very quickly. There's a magenta LED configuration. So as I said, you need both a green and a red phosphor, typically in displays. So not all phosphors have on-chip reliability. KSF does. So you can deposit that right on chip. When a luminescent material is deposited on chip, it experiences higher temperature. It's typically encapsulated, so it will encounter humidity, and it has higher blue flux. So if your material doesn't have on-chip reliability, something like say a quantum dot, then that would be typically used in a remote part that's encapsulated. And so this magenta LED concept is KSF on chip. It may be a standard size LED, or it might be a mini LED, and then you would use that with a remote green containing luminescent material. A third architecture that has been commercialized recently, say in the past 2 years, is you can also add KSF to the remote part if you wish. So we developed a new type of KSF, decreased the particle size by about a factor of 10, so that it can be used in combination with green luminescent materials that may not have on-chip reliability, but may provide other performance boosts, such as an increase in color gamut, for example. So this is commercialized in several products today, and we look to grow this market. And then finally, I'll finish the talk today talking about micro LEDs, of course, and luminescent color filters as well. They actually both require a submicron type of KSF that we've developed. So this is really the holy grail of color conversion, because what you're trying to do is you have very small LEDs, of course, and you're